All right, I think we're good. Everyone can see my screen okay? The iPad screen for the seventh grade algebra. All right, a little bit lower on the numbers this time. I think we've had around 50 people. We have around about a full class in here. Two of the people are me, so 34 people. All right, let's get going. So today's agenda, the first few I kept kind of the same, right? Delta math. So every week, if you're, maybe there are a few people here that this is the first time you're here. So I'm going to talk very generally every time I talk. Delta math, each week I've been posting Delta math, I don't know what you want to call them, assignments, to basically practice what we've been doing that particular session. So last week I posted a bunch of factoring categories, and I saw a few people comment. I didn't get to respond, but like, hey, is this required? Keep in mind, this isn't homework. You're not getting a grade for this, so I can't really say it's required, but it's a good idea. One, to practice what you just learned if you're in the session. Two, if you weren't in the session, but you followed the notes of the video. The purpose of me recording, not everyone can make it. I do see that people are watching the video and see, has views. If you watch the video and you're like, hey, let me practice this on my own. Also, we use Delta Math during the school year for classwork homework. So it's just good to get used to that platform as well. Did anyone encounter any issues with Delta Math? Specifically about the platform itself? Not, we'll do a little factoring review. If you have a factoring question, hold on to that for a moment. But any Delta Math specific, like, hey, I know 2 weeks ago or last week, some people were saying they weren't sure how to type things in. Did we encounter any weird examples? I'm pulling up the assignment now in Delta Math. Ooh, a lot of people did the whole thing. Wow, okay. Yeah, and one thing that I want to go over, we did it, if you remember, like kind of rushed at the end, factoring when A is greater than 1. I did put that as a category. I showed you guys kind of the textbook way of doing it. It's called factoring by grouping. But I'll show you a little shortcut. Like I said that at the end of last week. We just ran out of time. So we'll start this week. We're not going to do factoring again today. We are going to do solving equations. But we'll start with a few minutes on factoring. Any factoring related questions? Delta math stuff? Delta math was okay? Are we liking Delta math? Are we hating it? All right, I think we're good. Okay, yeah. I mean, it seems like I get like a little overview screen of how you guys did, what percent you did. A lot of people did the entire assignment. And sometimes it does take, I see some people are like perfect across the board. If you got a few wrong, that's fine. You're supposed to, one thing that I find with Delta Math, like, let's be honest, right? You guys have only done like 2 things on it, but eventually you get to the point where you're like, oh, I'm sick of this. I don't really like it. It does have a very nice purpose, which is it shows you if you did something right or wrong, and then it explains what you did wrong, shows you how to do it correctly. And people don't take advantage of that. They get mad that they got it wrong, and they just click to get the next question, and then they'll ask me. They're like, I don't know why I'm getting this wrong. So if you do get a question wrong, take a moment to kind of look it over. Don't just speed run through it to say like, hey, I want to get my 5 or 10 questions done. Make sure you're kind of taking it all in. Again, I can't really say mandatory because it's not like you get a grade for the summer, right? Like, let's say in September, if I say, hey, do Delta Math tonight for homework, then it's mandatory. It's like, hey, if you don't do it, you get a 0. If you do it, you do a nice job, you get 100. Can't really call it mandatory. I would say recommended would be a better word. Yep. They also give you examples. Very good point. Again, people get, like many things in life, people just kind of get caught in, the motion of things and they just fly through it, but it has a lot of nice resources. I believe, I forgot this, is it Bronx Science or remember someone telling me this a while ago, a student that went to Bronx Science after 67, but I think a teacher at Bronx Science or one of the specialized high schools actually like was the one that developed Delta Math. It's actually like a New York City teachers website, very popular site. A lot of you guys, when you go to high school, your teacher will also use it. It's not like a, an underground site. Very, very popular for math teachers. More so high school. So if you're like, hey, why have I never heard of it? It doesn't have a lot of like elementary or it has sixth grade stuff, but I don't think any of the teachers in our school used it. Supplies. I'm going to talk about this again. Graphing calculator questions. Can someone type in the chat, what calculator are we looking at for next year? What type of calculator do we need? TI-84. Any TI-84 works. The plus CE is the common one that you'll see. Amazon. Where else do you go? I don't know. Target, CVS, Staples. TI-84 plus C. Any of those work. Do you need to run out and get it before the first day of school? Some people are going to panic. Your parents are going to panic and think like, oh man, you need it. No, it's not an emergency type thing. I would say definitely get it the first, maybe after the first few days of school that weekend. Get it early on. This way you get used to it. If you have an older one, those also work. TI-83, a TI-84 earlier model. They used to just call it the Plus, and then I think before that was just the TI-84. Any of those work. They're just a little bit bigger. They're not color. They're not fancy, but it does all the same math stuff. Yep, perfect. All right, so we'll take a look at no questions from last week or supply related stuff. Going once. Okay, we'll do a little factoring review, and then we'll take a look at solving equations. iPad's a little low on battery, but hopefully I can always charge it if it runs low. All right, so with factoring last week, we learned a number of strategies. I want to say if we put it all together, we could break it down into 4. Can anyone give me one of the factoring strategies we learned last week? What was one of the factoring strategies that we learned? Oh, right on here, I guess. GCF, very good. Some of these are like, obviously GCF is a thing. Some of these don't really have like a fancy name, or teachers or textbooks will vary what they call it. So keep in mind, it's not technical. GCF, I would say, is the one that is. A greater than 1, very good. That has a number of names. Textbooks will call that AC method, because if you remember, that's one of the first steps where you multiply the first number and the last number together. Students in my class end up calling it trash method. We'll talk about why, and I'll show you that strategy today. We didn't cover that last week. I don't know if I said that name last week. If I got your curiosity now, like why is he calling it trash? Dots. Did anyone say dots? I've seen textbooks and different teachers call it different things. I call it dots. I've seen dots with a P, perfect squares. I like the T for 2 in there. I've seen DOS, DOS, but dots, difference of 2 squares. We'll do a little recap on that. And then I guess just our regular trinomial, we call sum product. That was when like A equals 1. Okay. So like I said, a number of these we are going to be covering during the actual school year coming up. So we'll have lessons dedicated to these. So anything we get out of this summer is going to be a head start, because we will be practicing it again as the year comes up. Okay, GCF, something that I think we all had experience with, greatest common factor. That deals with pulling out the greatest common factor that each term shares. For variables, the rule is each term has to have that variable, and then you take the smallest exponent, because that will be the most that they all have in common. It wouldn't make sense to take the highest exponent, because not every term has that many. And then obviously your coefficients are just regular number GCF rules. Hey, what's the largest number that goes into 3 and 12, right? Next, we'll go to sum product. Sum product, I'll put it easier when you have an example. Some product was our classic trinomial. Trinomial meaning 3 terms. We have a squared to the first, to the x, and then a constant. With trinomials, we double bubble, 2 parentheses. We put an x in each one, right? We connected this to box method from the week prior, where it's like, hey, when you multiply these out, we drew the 2x2 grid, x times x is x squared. Factoring is doing the opposite, it's breaking it apart. And some product dealt with finding 2 numbers that add up to this, but at the same time, they need to multiply to this as well. It's a little bit of a puzzle, right? We make this little diamond, and you're searching for these 2 numbers. Like in this case, what 2 numbers add up to 8 and multiply to 12? 6 and 2. Once you find your 2 numbers with some product, you're done. Doesn't matter which one goes where. You could check with all factoring strategies, you could check by multiplying it out. 6x plus 2x gives you 8x, 6 times 2 is 12, and obviously the x times x gives you x squared. Okay, some product, GCF. Let's talk about dots. Dots is a fun one. Dots, I would say, is not difficult to do. It's difficult to recognize when you're removed from, obviously, just practicing it. Like seeing it in a random problem. So this one, for example, this might not be a good one, because we have GCF. DOTS is an acronym which stands for difference of 2 squares. So it's kind of like, remember we did that slide last week where we talked about like, is it DOTS eligible or not? Like, hey, could you actually use DOTS here? Obviously we know this one is going to be, but let's talk about why. It is a difference, as a subtraction sign. Okay, it's 2 terms, so DOTS only applies to binomials. And perfect squares. Perfect squares refers to 2 things. The numbers, so 4 and 49 are what we call perfect squares. They can be written as an integer to the x power, right? 4 is 2 squared, 49 is 7 squared. To the second power, I should have said that. For variables, all you need to have is an even exponent. So the exponent does not have to be perfect. 10 is not perfect. It just has to be even. Because when you take the square root of a variable, let's say y to the 6th, all you do is cut it in half. Because remember how perfect squares or square roots work, right? You're multiplying something by itself. Just like how 25 is 5 times 5. With variables, if it's y to the 6th, I could cut that into 2 equal groups of y3 and y3. And now using our exponent rules, we know we add those together to get y6. So all you need to be as a variable is an even. Because if you're odd, you can't get cut in half, evenly at least. Okay. And now once you recognize that it is dots, we double bubble. We put opposing signs. Does anyone remember why do we do that? When we double bubble, why do we put 2 different signs? Why do I put a plus and a minus? Yeah, if we were to multiply this out, if I were to box this out, right? Usually when you do a 2x2 box like this, you're going to get 3 terms. You get first term, a middle term, and a final term, right? If we put the exact same thing in each bubble, but different signs, that middle term will drop out. And that's why we get this binomial. And now you just take square roots. Square root of 4 is 2. Square root of x to the 10th, chop it in half, x5. You're going to put the exact same thing in each bubble, aside from the plus minus. That's why I like to do that first. And now square root of 49, don't say 24 and a half, 7. And people take cutting in half too literally, and then they start cutting everything in half. And once again, you could check this if you wanted to by expanding and multiplying it out. That middle term will drop out. We have a positive version of this and a negative version of that. That's why you have no middle term. Okay? And the final one, I keep saying my AirPods are connected. Our final one, A greater than 1, is what I wanted to start with today, aside from doing this review. I know we're not starting. Because we didn't get to talk about this. This is ultimately what a lot of students end up doing. Factoring A greater than 1 can get a little tricky. If you remember from last week, it's very, not that it's very difficult, but there's just a lot of steps. It is related to some product. So you're searching for 2 numbers, but then there's a number of other steps. Okay? Trash method is a little bit more user-friendly. while not technical, students like it because it's a little quicker, it makes a little bit more sense in their head. So let's use an example as a way of, and trash method is what I call it. Again, this isn't like a technical strategy. Let's use an example to make sense of this. So we call this an a greater than 1 example because of the presence of this guy. The fact that there's a 3 there changes things. Because if there was just an x squared, then it would be some product. Hey, what adds up to this and multiplies this? Okay, I'm done. Those are relatively easy. Okay, especially once you get comfortable with the finding numbers process. The fact that there's a number there kind of throws a wrench in our plans. Because now we can't just put x and x, it's 3x and x in our bubbles, and then it matters what number goes where. It's a whole mess. So even with trash method, we are going to start off the same way, which is when we do sum product, we're looking for 2 numbers here that add up to 16, but in this case, we're looking for 2 numbers that multiply to 15. Where do I get 15 from? When a is greater than 1, you multiply those 2 numbers together. I always say with this step, you are going to catch it if you forget, because let's say I did write 5, there's nothing that works. Okay, what's 2 numbers that add up to 16 and multiply to 5? Nothing. So hopefully that will catch it and be like, oh yeah, I need to multiply those 2 numbers together. Okay? I have had students call this like eyeglass method because it kind of looks like a pair of glasses. Very spaced out, but a pair of sunglasses or something. Now, once you find your 2 numbers, which we'll do here in a moment, we're not done. We're still kind of in the middle of it. Can anyone tell me the 2 numbers that work here? What 2 numbers add up to 16 and multiply to 15? $15 and 1, very good. Okay, remember, we're not done. If this was some product, we'd be done. And now this is where we're going to change it. Because factoring by grouping, I'll quickly talk about it, but that was, you then rewrite 16x as 15 and 1x. Okay, you factor the left side, you factor the right side, something should happen. We called it a common bubble. I'm not going to talk about that way. That's kind of like the technical way of doing it. Again, this was all about trash method. Okay, so now what we're going to do, this is the step that seems a little weird at first. So we're going to double bubble. Now this isn't our final answer. You'll see why in a second, but we're kind of using this as a stepping stone. Okay, and I'm going to put 3x in each one. The reason why I'm putting 3 is because that was the first or lead coefficient. I feel like, where'd you get 3x from? Okay, whatever the lead coefficient is, that's what you start each of your bubbles with. Not the x squared, just the number itself. So 3, put an x, 3x. Okay, if it was 5x squared, each of my bubbles would have been 5x and 5x. Now, obviously, this isn't correct right now. If I were to expand this, even before we consider what like the next numbers are going to be, that would be 9x squared. So keep in mind what I said, which is this isn't our final answer. We're using this as like a stepping stone. Now, the 2 numbers that we just found are going to go in each bubble. So 15 and 1 doesn't matter which one goes where because remember we started each of them with 3x. So it doesn't matter if you put 1 first. And yes, this is just again, this isn't our final answer. This is just like a little trick strategy. Now, what you're going to do is, this is why it's called trash. You're going to look at your 2 bubbles. Remember, this is not accurate. If I were to expand this, I wouldn't get anything close to what my original trinomial was, right? Why it's called trash, we're going to search for a GCF. So in that first bubble, is there a GCF? 3x plus 15? Is there a GCF there? Yeah, 3. We're going to divide out a 3. And why I like to call it trash is usually with GCF, you're taught like, hey, factor it out and put it in front, right? Here, we're emphasizing the fact that we're throwing this 3 away. So I'm dividing out a 3 and it's gone. I'm not going to put it in front. So if I were to divide that by 3, I'm left with x plus 5. I'm not going to do this Okay, that's how you should do GCF, right? So the reason why it's calling trash, I'm trashing that 3. I divided it out and it's gone. Is there any GCF in the second bubble? Is there any GCF in the second bubble? Do 3x and 1 have anything in common besides 1? No. So if you don't have a GCF, I'll just put an X. You just stay as is. And this is our answer. So to recap, the beginning is going to be the same. So you still need to do the eyeglass, the AC, AC referring to 3 times 5. That's the A term and the constant. You still need to do that. You still need to find your 2 numbers. So the beginning half is still the same. It changes in the end. Okay, remember this is a little bit of like a tricky, gimmicky way of doing it. In actuality, you are still doing factoring by grouping, just in a different light. Where I got 3x and 3x, even though that's technically not correct, I'm just borrowing whatever the lead coefficient is temporarily. And then I'm throwing away anything they have in common. I know I took a long time like explaining that, but this does, I promise, end up being a lot faster than grouping. People tend to like this a little bit more. Is that, battery's not doing so hot. Does that make sense? We'll try one out using trash, or if you really like factoring by grouping, there are usually a few people you could stick with that. That's the technical way. That's how textbooks would do it. That's how Delta Math, for people that did the assignment, shows you how to do it. All right, why don't you guys try this one using trash? Try this one using trash. We don't factor with, sometimes people do like a guess and check approach with factoring. They're like, oh, I can figure this out. I think this goes there, and then they multiply it and they see it and they tweak it. We do want to have like an algebraic process for factoring. We don't do guess and check with a lot of things. Okay, if it's a multiple choice question or something, you want to do quickly, but if we're like showing our work, we want to know how to do it algebraically. Try the bottom example using trash. I'll give you a few hints. I promise we are studying a new topic today, but I did want to talk about this. How many people have, I posted an older video that I made. I don't think I talked about trash in the video. Maybe I did. How many people have seen something like this before? Trash. Seen something like it, maybe called it something different. One thing I've seen people, their parents, more comfortable with math. I don't know if it's taught somewhere, like after school or something. I don't even know how to exactly do it. Something like that, like kind of write your 2 numbers, and then there's some weird. That's another way I've seen some of my students do, but I don't teach that way. Oh no, the 5. There's some weird system like that. I always see like 2 or 3 kids doing that, and I try to like look over their shoulder, like, oh yeah, my mom or dad showed me that. Guess it's kind of related to trash. No one's ever seen this before. This strategy for factoring trash. We all learned something new. All right, let's take a look. So remember, you still need to do AC. AC, eyeglass, the first number times the last number. That's going to give us 60. We don't want to use 12 as our product. Our product is going to be 60. And our sum is still going to be the middle term. just like it is in regular sum product when a is 1. So now we're looking for two numbers that add up to 19 and multiply to 60. Can anyone tell me what those two numbers are? What two numbers add up to 19 and at the same time multiply to 60? 15 and 4, very good. Remember with some product, you want to be careful of false positives, like things that seem like they work. There's not really any good ones here. But sometimes, there's another pair of numbers that really seems like it should work, but it just quite doesn't. Especially when negatives get mixed in, that's where it gets a little confusing. So we want to use some of our tricks or some of the examples we saw last week. When there's a negative product, right away, it's opposing signs, or a positive and a negative. If it's a positive product and a negative sum, each number is negative. There's little tricks like that. I wouldn't even call them tricks, but little things like that definitely help out. All right, now practicing a trick that we just learned. We're going to double bubble right away. So we put this. And what should I start each bubble with? Remember, this isn't my final answer. What should I start each bubble with? 5x, very good. Whatever the lead coefficient is, that goes in front of x. So imagine it says like blank x, blank x. Whatever the lead coefficient is, that's what goes in front of x. Obviously, this is not accurate, so I would not want to do like something like this, right? Say like equals. I'm like using this as a step. And now we're going to put the two numbers we just found. Does not matter because they are the same. Doesn't matter which one goes where. And we're looking for GCFs and tossing them away if there is one. So in the first bubble, we have a GCF of 5. If I toss that away, what am I left with? Basically, if I divide it out, right? I'm left with x plus 3. Is there a GCF in the second bubble? No, there's not. Sometimes there is a GCF in each one. If you're like, oh, is this always going to happen where one of them has it, one of them doesn't? No, sometimes each of them has it. And that's our final answer. X plus 3 times 5x plus 4. Like I said, much more user-friendly strategy. So obviously students tend to like this one a little bit more. Also tends to be a little bit faster and grouping. Doesn't matter the order. Multiplication is commutative. Okay, what do we think about this? Do we like trash better, or I'll quickly just show you. This is what we did last week if you weren't here. So once we found the two numbers, we said split up 19. So we're creating a 4-term polynomial, and then you're like factoring it in half. So if I do the left side, I get 5x times x plus 3. If I do the right side, I get 4 times x plus 3. If you did it correctly, you should always get to the point where these bubbles, these binomials are the same. You then pull out that bubble. So I'm factoring out an x plus 3, and in your second binomial goes the leftovers. So the 5x and the 4. Like what was left behind when you pulled that out. You like trash? Yeah, people tend to like a little more. Okay, cool. So I did want to show you guys that. Again, these are all things that we cover again in the school year if you're confused. Hopefully it gets you going. Factoring is not a very popular topic. I like it. It's very, black and white algebra-wise in terms of algebra skills. Very concrete. But, people, I don't know why. It gets a little confusing. There's a lot of strategies to keep up with. I can see it, I guess, but why people don't like it. But something that hopefully with these, summer videos and summer sessions helps you out as we start it. Not something we do right away, but it is one of our earlier topics. Like I said, probably October, November, we'll deal with factoring and polynomials in general. Questions before we close the book on factoring? Nothing? Okay. So I originally wanted to, talk today about equations. We'll talk about solving. Another topic where it's like, obviously in sixth grade, you did some solving. Um, I think more so just like one step, maybe two-step equations. Technically, two-step equations is a seventh grade standard. So I know some of your teachers go a little bit above. You probably did, more difficult examples with solving, but we'll talk about solving linear equations. That's a name that maybe you didn't even know was a name. There are other equations that we'll learn throughout the school year later on, such as quadratic, other examples as well. So this is just solving linear equations today. Okay. As always, I say always, and we've only met a few times here, but I'm posting notes more so just, oh, the spacing is weird. More so for me as I'm talking, I like to have something to kind of refer to. Do you need to sit here and copy this down? Some people really like to. Some people are notes people. That's fine. I do post these on Classroom, so you can always refer to them later on. Okay. So let's talk about this. What is a linear equation, first of all? That's technically the name of what you probably did in sixth grade math this year. When you solve, I don't know, some of the examples you guys do, 6x equals 24, or 2x plus 1 equals 11. That's a linear equation. Okay? It has a variable to the first power. When you start involving other exponents is when you become another type of equation, which we will get to this year. We'll deal with x squareds, which are quadratics. But for linear equations, there are three possibilities. You didn't really dive into this, I'm assuming. Okay, linear equations can have 0 solutions. They most commonly have 1 solution. That's what you guys mostly dealt with, right? Hey, 6x equals 12. Okay, x is 2, 1 solution. Or they can have an infinite number of solutions. There's really 3 possibilities. Now keep in mind that doesn't say infinity, it says infinite, meaning everything is an answer, not infinity itself. So infinite means every single real number works. Okay, we'll use that bold example there as a little walkthrough in terms of some of our solving steps, which I have on the bottom as well. It's tough to put, I always find when I'm doing some of the first few lessons on solving equations, it's difficult to say like, hey, these are the steps, right? Like do this, then do that, then do this, and you're done. Like we did with factoring, right? Hey, with factoring, do this, that, do that. The reason why I say that, every equation is going to look different. I can try my best to put notes like, hey, distribute first, then subtract. And then there's always going to be, a weird example where all of a sudden those steps don't work. So what I like to do instead is just kind of give general bullet points of what you should be doing. Okay? And if you know these in and out, you should be good for any weird example that pops up. So your main goal when you're solving an equation is to isolate the variable, obviously, right? What does that mean? Get the variable all by itself. Inverse operations are used to quote unquote rid terms. So if I want to move something over, if I want to get rid of something, I do the opposite. That's what inverse means. If I want to get rid of that plus 17, subtracting 17 gets rid of it and moves it to the other side, right? Equations must always be kept balanced. Your teacher in elementary school probably did some analogy with like a scale or something, right? Like, oh, if we take off 5 pounds, we got to balance it off. So equations do always have to get balanced on the left and right side of the equal sign. Whatever you do to one side, you do to the other. Easy concept. Before moving things around, clean up both sides of the equation. So before you start playing the game of like, let me move this over here, clean it up. Like right now, the example, which we'll start in a moment, there's some work for me to do. I could distribute in this case. I could combine some like terms. That's what CLT stands for. That's not always going to be the case, but if it is, make sure you do that first. Condense things, right? When you go food shopping with your parents and you help them bring stuff inside the house, you don't like walk in a bag of chips, then walk back to the car and grab, a thing of milk. You put it all in, you condense it, make one nice bag, or you try to do one mega trip where you put like 10 bags on your arm. So we condense things first, and then we just do one trip rather than doing 50 trips. And then you can always check your solutions by testing. What that means is when we're all done, we do have a safety net of like, did I do this correctly? Did I get it correct? By plugging it in, and we'll talk about that. Okay, all right, let's see. I'm pulling this again, I can't write on my left. Okay, so I'm gonna zoom in for a moment. So if you are jotting that down for whatever reason, I'll zoom back out after, but just so we have it nice and clear here. If you want to do this example with me in your book or wherever you're writing, that's fine too. If you want to just watch, that's also fine. Okay, so what I'm going to do first here is, there's nothing really for me to do on the right. It literally just says -1, but I do have some work to do on the left. I can distribute first. Distribute, what are you looking for there is a parentheses and something in front of it. So in this case, I could distribute the 4 to both the 2x and the -1. Maybe it's a negative sign in front of the parentheses. You can distribute a negative. Maybe it's a number. In this case, it's a 4. So 4 times 2x gives me 8x. I got -4. I like to copy the rest of it down. I don't like to do the thing where you just like put an arrow. It gets confusing. You make a mistake. It's worth it. Take 10 seconds. Just write the rest of it down. And now, good review here from what we talked about 2 weeks ago, combining like terms. Does anyone see like terms I can combine? Excuse me. Does anyone see any like terms I can combine here? 8x and 3x, very good. Remember, when combining like terms, we do always want to make sure the sign's in front. So notice I'm kind of, some people will circle or color code or something. I'm just underlining here. But I want to make sure that is a +3 and a +8. So if I combine those, I get 11x. It's a positive, but I could just write 11. And I can also combine constants, regular numbers, -4 and +17. If I combine those, I get 13. Okay, some people doing this quickly will put 21 or something because they're just adding 4 and 17. That is a -4. So adding that with the +17 gives you +13. And now that's set equal to -9. Okay, so to recap so far, we distributed, we combined like terms, and now we're at the 2-step equation phase. There's 2 moves for me to do here, right? Keep in mind what we said earlier. Our end goal is to get that by itself. So what we're gonna do is work from the outside in. In other words, what's furthest away from the x is what we're gonna get rid of first. So that +13, if I wanna move that to the right, the opposite of adding 13, I'm gonna subtract 13. I'm going to do that on both sides. So people will do this, that's fine. That's kind of like the middle of your scale. I think it just serves as a reminder for some people, like, hey, make sure I'm writing the same thing on the left and right of that. So +13 minus 13 slashes out at 0. On the right, I have some math to do. -9 minus 13 is -22. Now, last but not least, I'm going to divide 11 and x are getting multiplied together. So the opposite of that, multiplication, would be division. And I get an answer of -2. If you want to be fancy, you can put one of these. Does anyone know what this symbol means? Three little dots. Who knows their math symbol? Very good. Therefore. It's kind of like in, when you write an essay in like social studies or ELA, what do you usually say? Like in conclusion or something, your last line. In math, that's like the version of that. It's like, all right, I did all this work, and in conclusion, the answer is -2. Therefore, x equals -2. Very good. And that's it. Now, 3 lines. Oh, what would that look like? I've never seen that. Yeah, just the 3 dots like that, little triangle dots. If you wanted to, I'm not going to go through it here, but if you wanted to verify or check this, you could plug in a -2. So you could sit there, everywhere that you see an X, you replace it with what we just figured out X to be. And if you did this correctly, you should get -9 equals -9 when you do the math. If you get anything else, you mess up somewhere. Maybe you made a negative sign mistake. Maybe you made an arithmetic mistake. But you do have that fail-safe of like, did it work? There's calculator strategies as well that we'll talk about, in class. Your calculator doesn't have like a solver in it, but there's things you could do on there, graphing related, to verify that this does check out. Some of the nice things about our calculator. Yes, we will be doing, like, I wouldn't say lessons dedicated it, but when we learn something, we'll take some time to be like, hey, this is also how your calculator can help. I have an emulator on my laptop, meaning like I have a calculator that pops up, shows you the buttons and stuff like that. We don't just, it's confusing if you're just like, hey guys, hit this button. And then 30 people are like, what? So I have a calculator on my laptop that I could, screen share and show you guys. Maybe, let me see. Doesn't take too long. That might be a good preview to do now. Any questions with what we just did? How many people have a graphing calculator right now in front of them? You don't need to, just out of curiosity. Okay. So what I might do for a moment, at the very least, it can't hurt. I'm going to show you guys my emulator. They call it TI Smart View. Okay, so I'm going to stop. Just going to take some time. I'm going to stop sharing right here, and I'm going to share quickly my laptop. It's a good little preview for calculator stuff. Also, if you have a calculator, they're not letting me share. I hyped this up and it's not letting me. Maybe I'll just do this. Oh man. That's disappointing. I have it up, but it's giving me some issues with sharing it. That's really strange. Let me just try one more time. I've definitely shared it. It's not like there's a legal setting for, stopping me from doing it. Maybe just some weird glitch. Give it another minute here to try it. That's really strange. When I try to share, it's just black, right? Like, do you guys see anything, or it's just a black screen? That's really strange. Huh. Okay. Can I try this? I have one idea. I'm not going to walk through the example, but I'll show you guys just so you know I'm not crazy also. Okay. I don't know if you could see. This is just what it looks like. First of all, it's not in my window. You still see myself, but there's another. The one that says rice math. There's another video that says that. This is just what it looks like on my end. So it's the same calculator. It makes the screen nice and big over here. So whatever I do type in, it also has like a little button thing. If you do get lost, like, hey, what buttons do you hit? As a key press history. For some reason, it's not letting me share it. Maybe something with Google Meet is down. I don't know. But okay. Let's go back to our lesson. Okay. Share screen. All right, but yeah, the whole segue there are features on your calculator for checking and stuff that makes it a lot nicer. Okay, I'll zoom out. That was just a general solving equation. There's a lot of variation here, right? We could do, excuse me, a lot of different examples, right? And the other thing, sorry we didn't refer to this, is we got one answer, right? We got x equals -2. How can an equation have 0 solutions? How can an equation have infinite solutions, right? Those are like the exceptions to the rule. The most common type of linear equation is getting one answer. That's probably what everyone in this meet has ever seen before in an equation, right? Hey, I solve something and I get an answer. But what does it look like when you have 0 solutions? Let's talk about that one first. Can anyone think of an example of an equation that has 0 answers? Usually someone will say x equals 0. Technically, that has an answer of 0. So I'm talking about there's no solution to the problem. There's 0 solutions. Can anyone think of an example, an equation that doesn't have an answer? You can make it as, you don't have to make it drawn out like this one. You can make it as basic as possible. Can anyone think of an equation that has 0 solutions? What do you guys think? Very good, Ethan. Basically just putting the same variable on the left and right side and a different number. So x equals x plus 1. X equals x plus 2, right, is what he said. Anything like that. This equation would have 0 solutions. Let's think about why. We'll solve it in a moment, but let's think about why. Whatever x is, put some number there, 50. On the left, it's going to be 50. On the right, it's going to be one more than that. Are these ever going to be equal to each other? No. Okay? If I were to start solving this, then we'll talk about solving things with variables on both sides. I would move x over to the left, let's say. X minus x is 0. And on the right, I'm left with 1. So I'm left with a false statement, false mathematical statement, right? 0 equals 1. What the heck? What that tells me is this equation is always false, regardless of what happens, regardless of what gets plugged in. So what's the solution to this? Another fancy symbol. You could put 0 with a slash through it. That means the empty set, no solution, or yeah. You want to be careful. Don't say like, oh, the answer is x equals 0. Again, that's stating that 0 is an answer. This is just saying that there's no solution. There's 0 solutions to this problem. We do encounter that a little bit. You haven't really seen, again, this would be an exception, but don't panic if you start solving something and you're like, wait, this doesn't work out. What's going on here? Your answer would just be that sometimes that happens in math. The answer is there is no answer, which seems a little unfair, but that is a possibility that we now have to deal with. And in a similar tone, what do you think infinite solutions would look like? Can anyone give me an equation? Oh, sorry, Miko also had a good example. 8x minus 35 equals 8x minus 27. Yep, that have no solution. Can anyone give me an infinite case? X equals x, yeah. The same thing on the left and right. Okay. Obviously, it could be more drawn out where maybe there's like combining steps or distributing steps and it's not super obvious in the beginning. But basically, it boils down to the fact that it's the same on the left and right. Maybe x plus 5 equals x plus 5, right? Because now, no matter what I plug in, is it always going to work out? If I plug in a 0, if I plug in a 1, if I plug in a 2, if I plug in the same negative number, right? It's always going to be true. Every single real number is going to work here. Yes, we will do these during the school year. So yes, there'll be questions like this. Everything works. So in this case, you say infinite solutions. We don't have a real symbol for that, but you could say all real numbers. But yeah, infinite. Don't say infinity. Don't say x equals and draw your little infinity sign. Infinite solutions. Excuse me. Because basically everything that we plug in works. With this one, if you were to solve it a little bit further, you'd get to this point. 0 equals 0, which tells me that is always true regardless of what the variable is. So that's infinite, okay? Very, very common to get one solution, but these exceptions are important to note. They are an algebra standard, so we will be solving equations on a quiz, a test, a classwork, a homework assignment. And again, people tend to panic with these exceptions because you're like, wait, what? Like, I got 0 equals 0, but important to note, hey, it's just, the weird case, infinite solutions is what I'm going to write. If I get something that's always false, I'm going to say no solution. Okay, questions with this before I move on? We're going to look at some other types of equations as well. Can anyone tell me in the chat, like how in depth in your 6th grade math class did you guys get with equations? Did you just do pretty much one step? Did you do multi-step equations? Did you do variables on both sides? I'm assuming you probably did like 2-step equations and maybe that was it. That would be my assumption, but I don't know. Like, did you do something like this bold example during the school year? That would be pretty complicated to do. You did multi-step, okay. So like distributing, combining like terms. Oh, variables on both sides. Wow, okay. Awesome. Because those are advanced, advanced topics. So we'll talk about variables on both sides. Maybe some of the honors classes in 6th grade did, and okay. Yeah. So we'll just dive into this. I mean, if you know those basics, those bullet points that I had, because remember, like I said, it's hard to put steps because every equation is going to look different. If you're familiar with those bullet points, you can apply them to any problem. It's like, oh, we didn't do examples like this in my class. It's really not that much more. You'll see what I'm talking about. So in this case, we could just call this variables on both sides. If you notice here, instead of there being like just a 6 on the right, there's a 9x plus 6. So what I'm going to do here, I'm going to distribute. To start, remember, we always want to clean up. Always want to clean up. 5x minus 15 plus 2x equals 9x plus 6. If we combine 5x and 2x, we get 7x minus 15. So again, all I really did was the same thing as the last problem. I distributed and I combined my like terms. There's nothing for me to do on the right, so I'm just leaving that as 9x plus 6. On the left, I could distribute and I did combine two things, 5 and 2, to give me 7x. Now this is the step where it's a little strange if you've never seen this before, because you're like, what do I do here? I have like, something going on the left, something going on the right. It's not clear where I'm supposed to move things. There is really no right answer, but basically you want to start sorting this. What I mean is you want one side of your equation to have variables and you want the other side to have constants. The reason why I said there's no right answer, I could move the 9x to the left, or I could move the 7x to the right. It doesn't matter, as long as I just kind of organize it somewhat. Some people will say like move the variable, just to give you some sort of direction, like move it to the side with the larger coefficient. So for example, if I have a 7 and a 9, I'm going to move it to the 9 side. But it doesn't matter. You just deal with negatives if you move the 9 to the 7. Maybe some people just don't want to deal with negatives, and that's why they follow that rule. So I'll go ahead and do that. If I want to move a 7, it's a positive 7. I'm doing the opposite. I'm subtracting it. The reason why, it's going to cancel it on one side. That positive 6, I'm then going to move to the left. Since it's a positive 6, I'm going to subtract it. Okay, we have some canceling here. Positive 6 and negative 6 cancel. 7x and minus 7x cancel. And now I'm going to do my math. Negative 15 minus 6 is negative 21. And 9x minus 7x is positive 2. And now I'm at my one-step equation step. I'm at my one-step equation part. I don't know what word to use there. And now I'm just going to divide both sides by 2. Negative 21 divided by 2 is going to give me my final answer of, doesn't work out nicely here. You could just say negative 21 over 2. Negative 10 and a half. Negative 10.5. Okay, 2 doesn't go into 21 evenly. Improper fractions are fine as you get older. That's another thing that people get weirded out by. In elementary school, like your teacher would yell at you like, oh, don't, improper fractions are bad. We start using those more and more. People on math team know what I'm talking about with common fractions, right? You tend to just use those more. Like if I was solving this problem, I would have just wrote negative 21 over 2. Okay, you could leave it like that. There's nothing wrong with, they're called improper, but as you get older, I guess maybe the material gets so difficult that they kind of don't get as technical with how you write your answer. It's like, all right, improper is fine. Depending on what the instructions say. Sometimes the instructions say something else, but yeah, that's variables on both sides, that's called. I don't really have like one note for this. Let's see what I wrote. It says, if variables are on both sides, clean up both sides. That's what, that's pretty much always going to be your first move. Hey, clean up, condense what you can. Next, group the variables on one side and the constant terms, the numbers, on the other. Remember, there's no real rhyme or reason. People tend to have some, that they do out of just, a pattern. They're like, hey, I always like to bring my x to the left, or I always bring it to the larger side. Whatever you do is fine. In this case, I brought the 7x to the right because the 9 was larger, but you could do it either way. You basically just want to separate it. You want, hey, variables here, numbers there. Cool with that. And now we'll look at another one. This looks like just a two-step equation, just getting into some fractional stuff. I don't think we're going to have time today for rational equations. We'll see, but if I was solving this one, I would subtract 9 from both sides to start. And now if I want to get rid of that 3/5, okay, if I want to get rid of that 3/5, you can multiply by the reciprocal. That was the whole purpose of this example. So you could just technically say divide by 3/5, right? Because that's being multiplied by 3/5. But it's a little bit more direct to multiply by the reciprocal when you have fractional coefficients like this. Think about it. When you divide by a fraction, okay, remember keep, change, flip, or whatever you learned it as this year, it changes to multiplication anyway. So multiplying by the reciprocal, the reason why that works, everything still does cancel. Just like how 3/5 divided by 3/5 is 1, same idea here. Okay, and obviously we do that on both sides. We even do this without a calculator if I think about it this way. 9 and 3, I can make 3 over 1, and 3 times 5 is 15. So if you have fractions in your problem, using reciprocals is a good idea to get rid of them. Just helps with the mental math part of it, I guess, a little bit more. We're just being able to recognize that. We're going to do some practice in a moment if you're like, hey, we kind of have a check-in here for a little bit. Questions? Ooh, okay. Yeah, I forgot to put this in here. Well, multiple choice. A big part of math is being able to, math doesn't really lend itself to multiple choice questions, but let's face it, every test has them, right? Every standardized test, and the Regents exam that we'll take later next June has, a good chunk of multiple choice questions, 24 of them to be exact. So being able to answer a multiple choice question is important. So let's pretend that, not pretend that they don't exist. So take a moment. Straightforward one, nothing too tricky, nothing too confusing here. Take a moment to solve this. No spoilers in the chat, please. After a few minutes, I'll ask you to type it in, but for now, no spoilers in the chat. Try to solve this one without just guessing. There are variables on both sides, and there's some cleaning up to do here. Did you guys get a ton of rain the other night? Was it 2 nights ago? I don't know how Queens, does anyone have like flooding issues? I don't think Queens was that bad. Suffolk County, I live in Suffolk County, on Long Island, some parts of it got 10 inches of rain. So people were stuck. Yeah, that was random. Came out of nowhere too, I feel like. They didn't really hype it up that it was going to be that bad. All right, if you want to type your answer in the chat at this point, you just put the number. You don't have to put the, 1, 2, 3, 4. Choice 4, a lot of people are saying. Let's see. A lot of 4s, that's either a good thing or a bad thing. Let's see. Hopefully it's a good thing. They're all saying the same thing. So the other nice thing with multiple choice in math, not that you just can go eeny, meeny, miny, moe, and guess, but you can substitute it in here. Like you could do this without knowing how to solve an equation, right? You could plug the choices in and see what works. Or let's actually just solve it as if it wasn't a multiple choice. So we'd get 3x minus 24 plus 4x equals 8x plus 4. I can combine 3 and 4 to give me 7x. And now I'm at that standstill step of there's nothing for me to combine. It's a little confusing, right? What to do? So however you want to slice it here, you just want to separate it. I'm going to move the 7x to the right. If you move the 8x to the left, that's also perfectly fine. You then just want to move the constant to the other side. Okay, negative 24 minus 4 is going to be negative 28, and 8 minus 7 is just going to be 1x. So this is actually already solved for. Because it is 1x or just x, it's done. There's no further solving needed. I don't have to divide. So the answer was correctly choice 4. Very nice. Okay. All right. What we'll do. Hmm. Save that. Okay. And I always try to. I put more things than I can get to in these sessions, and I like to kind of like see where we're at. Um, I'll quickly show it. We're not going to do it this week. We'll maybe talk about it at the beginning of next week. We will talk about examples like this. This is what I was talking about earlier. These are called rational equations when there's a variable in the denominator. Maybe there's a lot of fractions going on in the problem. We'll talk about strategies for that, but we'll save that for next week. What we'll do here is practice a little bit. And this might be difficult to do. Like one of those little, I don't know what you call these, little puzzle riddle things. We don't really care about that as much. But there's a bunch of these cleaning up, condensing problems. And basically how this works, let's do this. We'll do one together. I think that makes sense of it. Obviously, if it's a lot nicer if you have like, if we were doing this in class, I'd give everyone like a worksheet with this on it. It's a little annoying to do like on a screen, but we could still try to make the best of it. Let's do the first one. So you distribute, and obviously we're time dependent here. We don't know if we'll get to finish all these. Was there 20? No, 7 and 6. That was 13. Okay. 10n. I move the 10 to the left. And if I push the 28 over to the right, I get 30. For the first one, we're going to get n equals 3. Okay. Now, how this puzzle works, on the bottom row, see where it says 3. So it's kind of like a word bank. If I get something like 27 and I don't see it there, I know I messed up. So 3 is there. Not an automatic sign that I got to correct, but it's a good step. That at least I see it there. I'm going to put the letter E in that slot. Okay. I don't want to get too hung up on like how to do the puzzle here. I'm more so focused on the math, but that's how it works. So basically, when you solve one, you want to. It's a little annoying for you guys that don't have the paper physically in front of you, but if you want to fill it in as you go, I do have a PDF of this. So maybe what I'll do while you guys are starting it, I'll post the PDF for this sheet on the Google Classroom. If you really quickly want to print it or look at it in a different light, you can go ahead and do that. Yeah, if you want to just do it, go for it. And stay on here. We're not ending yet. We're just doing this for practice. I'm going to post it under session 3. If you really want to print it, let me go ahead and do that. We'll call this variables on both sides puzzle. Yeah, don't focus too much on the puzzle part of it. If you know how to solve all 13 of these, I would be happy. Where is that? I think this is it. Let's see. My Google Drive is giving me a little issue. A lot of technical problems today. But just do these problems. I'm trying to post it. Give me a second. Okay, it's posted. If whatever reason, if you, oh wait, is that a different one? Hold on. I believe it's posted. So if you really wanted the sheet in front of you, if you quickly print it, we don't have a ton of time left, around 10-ish minutes before I want to take a look at it. But if you really want it in front of you, it is posted under session 3 on Google Classroom under classwork. Might have been faster just for you to do the puzzle, for you to do the 12 remaining problems. Should spell out some answer to it if you did it correctly. Also, you could use the choices as a word bank. That's really the purpose of this. If anyone, while you're working, if you have any questions about anything else, if you want to type them in the chat, turn your mic on, good opportunity to ask as well. What level algebra? It's just called Algebra 1. It's actually the name of the course or curriculum itself. So Algebra 1, which is, if you're talking about grade level, Algebra 1 is technically like a ninth grade level class. It is a Regents class, so traditionally a high school. Your high school math classes are Algebra 1, Geometry, and Algebra 2. Your 3 core ones. And then you get into things like pre-calculus, calculus, statistics. But your 3 core like high school Regents classes are those 3. Algebra 1, Geometry, and then Algebra 2. Yes, Algebra 2 doesn't come right after Algebra 1. They do geometry in between. Mr. Sweeney in our building, if anyone had him for coding, Mr. Sweeney teaches geometry to the honors 8th grade kids. So the students that I had this past year, they're going to have Mr. Sweeney next year. You take the SH, SAT in 8th grade. Yep. Don't spoil the answer, but did anyone finish yet? Just out of curiosity? Or you finished all the problems, you didn't really care about the puzzle, which is perfectly fine. Yes, I know Abigail. I had her a few years ago. Yep. Tell her I said hello. 2 years ago, I had her? I believe she got 100 on the Regents too, if my memory's correct. I have a little wall in my room. Some of you guys have been in my room before. I have to add to it this upcoming year, but all the students that got 100, I have a little wall of fame. There's around a lot of names now, 30 something names, 35 names. We had 15 this past school year, which is a lot. We'll say like 2 more minutes, and then we'll try to quickly go through this, speed run this, if you will. good score on the Regents exam is, it's tough to say. It depends on, more so your personal goals. In my opinion, 90s, in the 90s, 90 and above. I've had some students that say like, oh, like from the very start of the year, I want to get 100. If I don't get 100, I'm going to be disappointed. That's kind of a tough goal to have because it's very difficult. Like I said, I'm going into my 11th year at 67. I have around 35 perfect scores all time, or in those 11 years. Some tests are harder than or easier than others. It seems like the past few years we've had a lot. Your sister's Abigail's class had 10. Last year we had 15. I had some years where I only had like one or two kids get 100. So it's difficult to say like getting a perfect score is, that's your goal. So in my opinion, 90 and above. Some people even say 85 and above. 85 is what we call mastery. So it is kind of like a cutoff. But yeah, anything like that. All right, let's try to quickly speed run this if we can. See how we did. How many people solved the puzzle part of it? Like you kind of know what this works out to. Anyone finish all the problems at least? So we got x equals 4 there. I'm going quick, so if anyone spots an error, let me know. We're going to have 19t here, 16 plus 3, minus 48. We have 14t plus 2, so it's going to be 5t equals 50, which means t equals 10. Yes, very good. That is the answer to the puzzle. See if I'm able to get close here. 6v, that's going to be negative 4v minus 28. 16 minus 28 is negative 12. Move the 18 over, negative 30. Negative 5. Be careful with this. Everyone look at I, the one I'm up to. When there's a negative in front of a parentheses, you do have to distribute that. So don't forget about that. So it actually becomes plus 3x. So 7x minus 9 equals 8x minus 1. That's going to be x equals negative 8, I believe. That's I. We're almost halfway there. We are halfway there, yes. 12y plus 36 equals 10y plus 40. 2y equals 4, or y equals 2. Okay, I am trying to go quick here. 26m minus 39 equals negative 7 plus 28m. So 2m equals negative 32. M equals negative 16. If you're keeping up with just the answer, I'm trying to write it somewhere near each one. I'll circle it maybe too. Here we get 99 minus 9k equals 9k minus 27. 18k equals 126. So that's 7. K equals 7. They. I know for a fact we don't use the 9 column, so it's a space. Now let's see if we can do the last 4 quickly here. 35x. 26. 30x. Minus 15. Is that negative 1? Do not go this fast in your own time. 12d plus 6 equals 18 minus 48, negative 30, plus 9d. 3d equals negative 36, d equals negative 12. Uh, 32u. So 20u minus 8 equals 22u minus 66. Negative 2u equals, why they use so many different variable letters here. Negative 2u equals negative 58. So 29. U equals 29 for the second to last one. And very last one. Distribute a negative here. You're going to get negative 15y combined. That's going to be a positive 1 combined with the negative 5 is negative 4. On the right, you get 14y minus 32 minus another y. So 13y minus 32. I'm going to move the 13 over to get negative 28y equals negative 28, which would give me negative 28y equals negative 28, y equals 1. So the puzzle here, the joke, I suppose, joke in quotes, is they fascinate. Why do girls like guys who wear shirts with 8 buttons? They fasten 8. Fasten is what a button does. Fascinate, it's a pun, it's a joke, depending on your definition of a joke. Hopefully mathematically we were able to follow that. I did quickly, and right in time, it's 10:30. I did want to, at least give you the answer set. Don't worry about the joke puzzle part of this. I'll leave this up. I tried to circle each one if you could see it clearly. My handwriting's a little sloppy when I go quickly, so let me know. Did we have any questions with these? Like, hey, I got this wrong. Go ahead. Yes, did I mess something up? They fascinate. Yeah. Question? Did someone have a question? I heard. Okay, stop the recording. Go ahead if you have a question. Type in chat, turn your mic on. Okay, thank you. I'm going to stop the recording.